Good evening everybody. So in the last class we had discussed about Ampere's law. So today we will discuss about the Lorentz force. So when a Lorentz force gives the concept that the force acting on a charge in an electromagnetic field. So that will be decided. The Lorentz law states that the force acting on the charge in an electromagnetic field is given by superposition principle. That means you consider the force acting on the charge due to electric field alone and force acting on the charge due to magnetic field alone. Then you take the vector sum. Now first of all, suppose this one is the field and this one is the magnetic field, and suppose this one is the velocity of this charge particle, and V, the angle between V and B is nothing but theta. So the force will be given by, so it will be perpendicular to the plane containing V and B. So if we take the magnetic field alone, so force is equal to F1 is equal to, so this is BIL sin theta. So and it will be Newton, and if you are just taking the unit vector, it will be A. And as it is perpendicular, it will be 90 degree. Now you see, so I can wipe out this one. This will be, if I will be representing this one by the unit vector, that gives the direction, that will be giving the vector form. Now we know that I is equal to Q by T, and this one is L and this one is sin. So L by T, I can write this one is L by T into Q into sin. Now we know that L by T is velocity. This is velocity into Q into sin. So I can write Q into V cross. So this is equation 1. This is due to the magnetic field alone. Now we know that the force acting on the charge due to electric field is given by F2. Suppose the force is F2, it is Q into E is the electric field. So this one will be given by, so I can write F2 is equal to Q into E, where E is the electric field. So according to Lorentz force, the total, suppose this one is equation 2. So the resultant force acting on the charge during electromagnetic field is given by F is equal to vector sum of F1 plus F2. So it will be Q into E plus Q into V cross. So I can write this one, I can take Q common, so it will be E plus V cross. So this one is the resultant force acting on a charge in an electromagnetic field. Now suppose we will take an example, we will do a problem based on it. Now suppose it is required to find out the force on a charge which is placed in an electromagnetic field. The charge is given by 0.2 coulomb, velocity is given 4I minus 2J plus 3K, and the unit is meter per second. First of all, we have to find out the force on the charge due to electric field alone, which is given by 20I plus 20K volts per meter. Similarly, second one, it is the magnetic field, which is given by 3I minus 5J minus 6K Weber per meter square. Then we have to find out the resultant force acting on the charge. Suppose first of all we have to find out the force acting on the charge due to electric field alone. We know that the force acting on the charge due to electric field alone is given by F is equal to Q into, so suppose this one is F1, Q into, so it is Q is 0.2 coulomb, so 0.2 into E is given by 20I plus 20K. Now if we will multiply, this will be force unit will be Newton. So it will be 4I plus 4K. So this is the force acting on the charge due to electric field alone. Now suppose for the second one, B bit, it is B is given. So we know that the force acting on the charge due to magnetic field is given by Q into, suppose it is F2, so it is given by Q into V cross B. So that means we have to take the cross product of V and B. So Q is 0.2 Coulomb. Now V cross B, this is the cross product. V is given by 4I minus 2J plus 3K cross, it is B is given by 3I minus 5J minus 6K. Now if you take the cross product, it will be 0.2 can be kept outside. So in determinant form I can write IJK, it is 4 minus 2, 3, and this one is 3 minus 5 minus 6. So if you will expand this one, it will be 0.2 into, so it is I minus 2 into 6 cross multiply, so it will be 12 plus 15. So 12 plus 15 is given by 27, so it is 27I minus J. Now you multiply this one with this one, it will be minus 24 minus 9. So minus 24 minus 9, it will be minus 33. So it will be 33J. So it will be 33J. Similarly, plus K. So you multiply this one with this one and this one with this one. So it will be minus 20 plus 6. Minus 20 plus 6 is minus 14. So minus 14. So you can find out this one. Now we have found out this one, that is due to magnetic field, this one is due to electric field. Now if we combine this one and this one, so that means F, if we are taking the force acting on the charge due to both electric field and magnetic field, it is given by F is equal to F1 plus F2. That means we have to take the vector sum. So it is 4I plus 4K plus this one, the second equation. So this is 0.2 into 27I plus 33J minus 14. So if you find out the resultant, then we can get it in vector form, and if you take the magnitude, it will give the magnitude of that one in Newton. So today, so this one we have discussed, that is the Lorentz force. In the next class we will be discussing. So today we have discussed about the Lorentz force. So that means the force experienced on the charge due to electromagnetic field. So in the next class we have discussed already the Ampere's law, but that is the inconsistency of Ampere's law, because we have derived that the equation what was derived, so that should be modified. So that is given by modified Ampere's law, which we will be discussing in my next class. So thank you all for watching. Please like, share and subscribe to my channel. Thank you all.